During the mass and change exploration, we talked about how to draw particle diagrams to represent different things happening. Throughout that process, we kind of developed a set of rules for drawing our particle diagrams. So here's what we have so far. When we draw particle diagrams, we need to show distinct, countable particles. We're going to relate the number of particles to the mass. So if you have more particles, you have more mass. Therefore, in order to do that, we have to have distinct particle shapes that we can count. These can be circles, they can be dots, they can be squares, they can be triangles, puffy clouds, whatever you want. On Notability, you can do them as different colors, so you can use all different types of things to differentiate between different particles. Second, if we have different substances, we have to represent them with different particles. So say we have sugar and we have water. Sugar and water are not made up of the same types of particles, therefore we need to represent them as two different kinds of particles. So you have to think about everything that's going on. And then finally, we said that the number of particles indicates mass. For now. Later we'll talk about sizes of particles and things like that. So here are just a couple examples from the exploration. So first, when we did ice melting, our data showed us that our mass didn't change. So in our before picture, we would draw our ice cube, and I said that it had 3 particles because it's easy to count. So I drew 3 dots, and then when it melted, since the mass stayed the same, we still have to have the same number of particles. So I still have the same type of particles, but they're spread apart to show that it's no longer a solid and now it's a liquid. When we dissolve sugar, now we have 2 things. We have sugar and we have water. I represented my water with blue dots and my sugar with green dots. Again, when we looked at our data showed that the mass did not change when we dissolved the sugar. So we can conclude that all the sugar particles did was spread apart. So in our after picture, we show the same total number of particles, 3 blue dots for the water, 3 blue dots, 3 green dots for the sugar, 3 green dots, just spread apart because the sugar dissolved. If we want to show mass changing, we either need to show more particles or fewer particles. When we burned steel wool, we saw that the mass increased due to a reaction between the steel wool and the oxygen from the air. So in our before picture, here's my lump of steel wool, and I said that it has 6 brown dots as particles. And in the after, I added 6 red dots to represent the oxygen entering the system and combining with the steel wool. So I have more particles in my after picture than my before, and that tells me that the mass increased. You can apply this to many different types of situations. You just have to keep in mind your 3 fundamental rules.